Hello. Cool. Hi, everyone. We are going to do a 30-minute talk with 3 speakers. So we've got 10 minutes each. My name's Luke Marsden from Dotmesh. Yeah, this is a Kubernetes kubeadm deep dive. So we all work together in the special interest group for cluster-lifecycle. And for quite a while now, we've been working on a tool called kubeadm. And so we're going to talk about that in a little bit of detail. I'm going to start by just giving everyone a sort of introduction to kubeadm and talk a little bit about the history and the formation of SIG-cluster-lifecycle, which is where we work on it. Then Tim's going to talk about upgrades, self-hosting, and HA, which are the areas where we're developing kubeadm in the future. And then Alexander's going to talk about using kubeadm in an enterprise environment. In particular in a lockdown environment where you might not have all the usual sort of access to the internet and nice things like that that you might be used to otherwise. So jumping straight into the intro and history. So if you sort of cast your mind back to September 2016, this is around the time that this all got started. And at the time, Kubernetes was insanely hard to install. There was this project from Kelsey Hightower called Kubernetes the Hard Way. Has anyone ever heard of Linux from scratch? Yeah, where you, a surprising number of people have heard of Linux from scratch, like where you compile your own compiler and stuff like that. Kubernetes the Hard Way felt a little bit like that. It was like you spin your own TLS certificates and you put them in all the right places and you start all the right containers and press go and then everything works. But it was really fiddly, and like Kubernetes the Hard Way was intended as a tool for, well, it was documentation for learning how Kubernetes worked on the inside, but it wasn't very great. It wasn't a great experience for people who actually just wanted a functional cluster. And also, to be honest, at the time, Docker had just launched this thing called Docker Swarm. And Docker Swarm was insanely easy to install. There was, I think it was like Docker Swarm init and Docker Swarm join, and that was it. And so Joe and the team working on Kubernetes, sort of, as a group, we all felt the pressure to be competitive with this user experience, and that's a good thing. I mean, that competition drove us to build something better. The other thing that was happening was that there were lots of projects to install Kubernetes sort of coming up, and everyone was sort of reinventing the wheel, and it was a shame that there was so much repetition of effort. So what we decided to do was to spin up this new Kubernetes SIG called SIG-cluster-lifecycle for managing the whole lifecycle and building tools and toolkits around installing Kubernetes, upgrading Kubernetes, and so on. So one of the first things that we talked about, and a really important decision that we made early on, was that we were not going to try and manage provisioning, bootstrapping, and add-ons. The reason for this was that there was a huge variety in how people wanted to provision machines. So I guess I should take a step back. The way you get a cluster is that you get some computers, and then you bootstrap Kubernetes on them, and then you install some add-ons for essential services like networking and storage. And we talked to people, and there were just so many ways that people wanted to get machines. Like getting machines was something that was tremendously diverse as in terms of how people did it. Lots of people like using Terraform. Lots of people like using CloudFormation. Lots of people want to work on bare metal. Some people want to use Raspberry Pis. And there isn't a consistent way. We realized early on that if we got into the provisioning game, that we just sort of get stuck in a quagmire. But that's the work that's now happening under the auspices of the Cluster API, and that's great. But we decided not to start there now, sort of back in September 2016. So we decided to focus on these 2 areas of bootstrapping and add-ons. I can show you how that works. So didn't have time for a full demo, but I'm going to take you through some screenshots of some terminals really quickly. The first release of kubeadm was in 1.4, and it looked a little bit like this. So step 1 is up to you. Get some computers running Linux. So you do that however you like. And by the way, kubeadmin was designed to be used, it was designed to be automated around as well. So one of the really nice things that happened soon after we released kubeadmin was that we saw lots of projects popping up on GitHub that used kubeadmin as an implementation detail of broader Kubernetes provisioning techniques. And we saw Terraform scripts that wrapped kubeadmin. We saw things that installed kubeadmin on GCE. And this was great. This is exactly what we wanted to happen. Because those tools, those projects were much, much simpler than they would have been without kubeadmin. So that was the point. So this is how you can create a cluster using kubeadmin. Step 1, install Docker. Step 2, install kubelet, kubeadmin, and kubectl. And these are all just apt-get install commands. At the moment, I'm assuming Ubuntu. Then you run kubeadmin init on the master node. Then you have a master node. And then you take the output of the kubeadmin join command that kubeadmin init spits out, and you paste that into some other computers. And those computers, where you've already installed Docker and installed the tools, you then run kubeadmin join, and now you've got your first node in the cluster. And then you do the same thing again, and now you've got your second node in the cluster. And now you have a 3-node cluster ready to go almost, except the state that kubeadmin gets you to is just a cluster that doesn't have networking working yet. And so you can think of kubeadmin really as a way of getting a bare bones setup. You can now, however, install some networking. So I'll use the example of using WeaveNet here. 2 lines, it's pretty easy. You can then add some more add-ons. So if you want to, you can install some storage. And I use the example of my project Dotmesh here. And then you have a cluster that's ready for your apps. So it's pretty simple. However, these kubeadmin clusters initially were hard to upgrade. When we got the first release out, we didn't yet have a documented way of upgrading them, and that kind of sucked. So that's something that we've since solved with better documentation. But there's also additional work going on to make that easier. The other thing that people really wanted was the ability to have multiple masters, and so to have high availability. So Tim's now going to talk about the work that's underway to solve those problems. Over to Tim.
Hello. So I'm going to be talking about self-hosting upgrades and HA with kubeadm. And those who have been around SIG-cluster-lifecycle for a while know that we've been talking about it for a while, right? So some of these things are really kind of hard. And Tim Hawkins had the feature corkscrew. Eventually it leads to a point. This is an example of a feature circle. Because if you change one thing, it will affect the behavior of the others. So we had to think long and hard about how we wanted to do things. And we also wanted to incorporate the best practices before we enabled these things. We're actually at a point now where I think we can actually get the first bootstrapping point into self-hosting properly done. So that way we can move on to the next points. We already have the ability to do HA, and we have the ability to do upgrades. But again, these things are interrelated. So what exactly is self-hosting, for those who don't know about it? It's basically running Kubernetes on Kubernetes, or you can think of it like a turducken, right? So we're only running it in one particular type of mode. If you look at all the documentation and ways to do self-hosting, we're only going to run the control plane. We are not going to run etcd in self-hosted mode. There's been a number of issues that have existed, and the CoreOS folks who tried to do it several times have given up on it. We're also not going to run kubelet on kubelet. That gets to the point where you have really weird behavior because you have to do a whole bunch of extra mounting of your kubelet into your kubelet. If that sounds confusing, it's because it is. It's not a good idea. But the primary reason for enabling self-hosting is ease of upgrades using the Kubernetes primitives. The whole sort of sunset horizon future is that you want to use all the same tooling that you use for Kubernetes to deploy and upgrade Kubernetes, right? So again, why does this take so long? There's deep tensions between feature enablement and a clean and simple UX. As Luke mentioned earlier, the purpose of kubeadm and its core concept was to make it easier. And what we didn't want to do is provide all these capabilities to do these things, but then be stuck in this weird configuration knob space there's no, it's like a hellscape. You can't escape it once you start it. So instead, we try to keep on thinking about things and distill down the best practices over time. Right. There's also a desire to be supportable. If you start doing these one-off implementations, you're kind of alone in the wilderness, right? And we don't want to have that support route going forwards, because a lot of times that becomes technical debt or a burden over time. There's also a legacy, a long tail of untenable supported configurations. People enable things, and then you're stuck with them, like I mentioned. But one of the major precursors for us doing some of these enablements, such as self-hosting some of the control plane components, is that we really want component configuration and version semantics around the arguments for the individual components, right? That is a key feature, which will be very nice. Hopefully in 1.11, we should have dynamic kubelet configuration in place that will ease a ton of burdens that exist currently with the many deployments. And last but not least, we have gone round circle many, many times about whether or not we should checkpoint or not to checkpoint, and what are the costs and benefits associated with that, and the security implications. So what's the status? I'd say it's still alpha with a single node environment. You can set up multi-node environment. It's actually better to do it that way if you are currently using kubeadm, because you have less chance of a single point of failure. You still have the DC outage problem with the current version. But currently we're trying to rethink the problem to avoid the checkpoint dilemma, right? And try to prevent us from having to constantly think about these things. When you're coming back online, there's an edge case that you have to deal with, which is basically you need a single point or bootstrapping point for you to come back online. So one of the things we're going to be writing up this cycle and hopefully get reviewed to implement next cycle is a Kubernetes enhancement proposal that I've called the Sentinel, or Joe has referred to as the pilot light. Right? So how does it work? What's the idea behind the pilot light? kubeadm deploys a single static manifest called the kubeadm Sentinel or pilot light. The Sentinel checks if an API server is running, basically a Sentinel file on the machine in a well-defined location like var run Kubernetes. If it's not there, it deploys a static manifest within its local /etc manifest location. Waits for the kubelet to check in. Once the kubelet check-ins, it'll find out that it has a bound pod to it. That bound pod will then be spun up, and the spun up pod that is actually a self-hosted container will contain a Sentinel marker that will drop on the machine, and then the original Sentinel will then shut down the API server. So upgrades. Again, upgrades are an artifact of whether or not you're using self-hosting and whether or not you're deploying an HA. So again, we're trying to distill the best practices, ensuring that we only rely on beta features. We actually got bit by some things that were updated via component config in the 1.10 cycle. So we have to work out the details there with the SIG networking folks. But last but not least, and as a community, we can always benefit from this. We need more testing and testing cycles. I don't know if any of you have ever taken a .0 release of Kubernetes and said, yes, this is the best thing to do and install this right away in my prod cluster, right? But if you're all laughing because it is kind of funny. But the idea is that we want to get our tests better, right? And we are building out more testing infrastructure and making it better over time. So if there's anybody who was new to the community and wants to contribute, that's a great area to contribute. And you have a lot of understanding from the outside looking in on how the system should behave. Okay, high availability. I wanted to take a little bit of time to talk about the way people conflate the idea of high availability. Because a lot of times people talk to us and ask us for high availability, but I don't think they understand what they're really asking and then how Kubernetes really operates. There's a conflation of HA of the control plane and HA of your workloads. Right? People always conflate those ideas. The control plane can completely go down and your workloads will still be running. And many times with auto-scaling groups on cloud providers, you won't even notice. The machine will come back online and your control plane just pretty much went away and came back. So instead, spend a lot more time focusing on your workloads. Those are the things that are important to your business. Those are the things that really matter, right? A lot of times, unless you're in a high churn environment where your workloads are coming and going all the time, HA adds a lot more complexity than it does solutions that it provides. right? So when you're checking off checkboxes, when you're talking to your CIO, make sure you check out our workloads are highly available, right? You can also provide extra learning for your masters and understand your tolerances for failure. What's your mean time to recovery that you care about? What's your mean time to failure? What's the flux rate of your cluster? How your workloads are coming and going and changing. So what's the status? You can do it all today with kubeadm if you want to. There's documentation for it. It's not the easiest thing in the world, but it's doable. So with etcd, there's documentation that exists to deploy your cluster in etcd. There also exists upgrade instructions for how to do it. We're coming up with better documentation in 1.11 to basically use etcd phases, or kubeadm phases, because there exists macro sort of behavior inside of the phases subcommand. Active API servers, it requires just a minor configuration change, and that's all documented. Controller manager and scheduler. The only thing I'm really kind of want people to think about over time, and we're going to add this behavior, is that when you're doing this, to try to lock on config maps, and we'll add that feature in kubeadm going forwards. And this is not a canonical example. There are many like it, and this example is also not purely HA because there's only one load balancer here. But it's just an example of what the deployment might look like going forwards. Very simple. But even though you've deployed an HA environment, that doesn't mean that it's all hunky-dory, right? These are the most common standard features that people ask for and they constantly query us on. But there's a whole bunch of other planning that goes into this. There's planning for ingress, there's planning for egress. We constantly get asked questions about air-gapped environments. Like, how do we get all our containers working in this environment in a totally air-gapped way? There's also load balancers, and that's all kinds of fun stuff that Alexander is going to talk to you about.
Well, thanks, Tim. So, hello, everyone. I'm Alexander Kanevskiy. I wanted to talk about the things which might be obvious for many of you, but looking at the issues what we getting in kubeadm since I think release 1.6, and like from different users, from what I myself stepped on, I wanted to cover a few things where the scenario when running kubeadm is not that smooth as Luke was showing in his screencast. So what's the problem? The world is not ideal. If you work for small companies, internet native company, you might have good internet connection, you have freedom what you want to use. But if you're in an enterprise, you must probably have rules like what kind of Linux distributions you are using, what kind of network policies you have. Well, in the worst case scenario, you're located in a country which decides which internet resources you want to access. So let's first look at installation and upgrades. So you saw in the screencast, Luke installed a couple of packages on Ubuntu. We are providing the Debian and RPM packages for most common distributions. We have also instructions for container Linux, previously known as CoreOS. The thing is, the support for those distributions and, well, the variety of distributions is wide. And the problem starts when you try to use our packages on the distributions that we don't support, or if some distributions try to provide their own versions of utilities, and you try to apply the kubeadm documentation on top of it, you get into problems. So my small how-to in that scenario is what? Don't try to mix. Select one thing. So if you follow kubeadm documentation, use the documentation and use the packages from kubeadm. If you select your vendor distribution, well, you're stuck with your vendor. But in reality, what those packages do, it's not a rocket science. They bring just few standard binaries to the system. So it's kubeadm itself, it's kubelet, the node agent, kubectl, which helps you to communicate with API server, and few standard CNI plugins which you need. Well, plus dependencies like to standard utilities like IP tables, whatever else is needed on your system. So again, it's not rocket science. If our set of packages doesn't match your environment, look at the examples and look at the documentation what Container Linux does, it's actually like just few shell commands actually to provide the needed binaries to your system. And you can integrate it into your own stack, like Ansible, Salt, whatever else you want to use. So second thing, we're fine-tuning. So our packages provides two systemd startup files. One for kubelet and one for a set of parameters which is kubeadm is expecting. For example, like bootstrap config for kubelet. So you can get it from the packages. You can get it also from corresponding release, from corresponding branch of our Git tree. The thing is, those parameters most probably not the one which you want to use. Documentation says go and modify this kubeadm conf. Probably it's not a good idea. My recommendation is create your own local drop-in for systemd, and you can easily override the parameters what you need to change. What it will allow you to do. You will see when the parameters on upstream, on our side, will be changing, and you will always know what you have changed in your local system. So, next thing, we're calling home. So we get set of bugs which says, like, I run with kubeadm init, and it's stuck with something. So we have several places where kubeadm accessing the network. Like one place is resolving version files. So you saw, for example, in Luke's screencast, is like he said kubeadm init and he got 1.10.2, like the latest release. What happens behind the scenes is what kubeadm go to download repository, read a special file, and resolves it like, okay, user wants to have latest version, so it's 1.10.2 at the moment. And we have support for a couple of such labels. So you can be like stable, latest and greatest release. You have stable 1, means like you automatically upgrade 1.9 to 1.10. And, or you can be more precise, like I want to stay on the 1.9 line. The same thing goes to latest label. Latest label allows you to get all the beta versions, release candidate versions, and so on if you want. Small hidden part, the CI part. So you can use the CI/something to actually get the images from Kubernetes, which is not really released, but you can try to use it. Yeah. So next thing, what Kubernetes actually try to do, it fetches the images from the registry. So all the images what we are referencing, it comes from our Kubernetes registry on Google. Two first images, the infrastructure one, like POS and etcd, they have their own release cycle. So if you want to do like really offline installation of your cluster, you most probably want to do yourself few steps to download and save it and then import on your nodes. The last 4 is part of our release process. So if you go to download server, for each release, we have directory which contains all the binaries, all the Docker images, so you can get them and then reuse it. Obviously, it's not browsable, directory browsable in the browser, but to get the list of files, what is where, you can use the Google utilities to actually get the content and then play yourself, try to find what is usable for your particular installation. Last thing, network part. The most scary thing for people who are working in enterprise. So the usual scenario, you have your network segment, you have your set of nodes, you probably have free connectivity between those. But if you go to outside world, you have a firewall. If you're lucky, you get a proxy, which you can get the access to external world, but this proxy most probably doesn't have access back to your LAN segment. And this is where like most of the confusions for people are appearing. So you need to configure this setup, like to explain to kubeadm and components where to go if you want to access different network resources. First part is your container runtime interfaces. It needs to be able to fetch the images. From outside world, you need HTTP proxy. For your local registries, you need to make sure what no proxy says. For those local registries, don't go there. Next thing is kubeadm itself. Again, same scenario. It needs to reach the download server, so HTTP, HTTPS proxy. But when no proxy variable, you need to have here 3 ranges. Like one range is LAN segment, because it needs to communicate to master over your normal IP addresses. And when the ranges which you are using for the cluster, so your service and pod ranges. Well, too long, don't read. Example.com, my domain, 192, it's my local segment. 10/8, it's the usual service where service ranges what we have in defaults. So many of the things what I said here, they can be detected by pre-flight checks. And what we observed many times in the bug reports is what the people either disable the checks or ignore the warnings or, well, skipped in previous versions. So one message which I wanted to say, don't ignore the checks. If we have something, most probably it will lead to problems. And if you see what checks misbehave, please come back to us, open the issue. We will look how to solve it. So thank you. That's what I wanted to say. And yeah, questions?
This pre-flight checks, can we disable granularly? Can we disable pre-flight checks in a granular manner? So let's say I do not want etcd to be checked because I know it is outside of my cluster, outside of the node, but I would like to have the rest of pre-flight checks to run.
The short answer is yes.
Yes, a bit longer answer. So specifically for etcd check, if I remember correctly, how it's currently implemented, it's able to detect what it's external. So it will go try to connect to it. It will check what its appropriate version. And if it's wet, it will just say nothing. If it will be something not satisfied, it will produce warning. And yes, for starting from, I think, 1.9 release, we have ability to actually fine-grained control over pre-flight checks. So if a check is producing error, you can say ignore pre-flight check errors, and when you put the check ID, like comma-separated list, so you can do multiple of those. So what it means, it will, like the check will still be running, the check will produce warning, so you will see what something is still not what we are expecting.
Sure.
So we have some on-prem installations where you have been lucky to use an HTTP proxy, but they do not allow internet access at all. So no HTTP proxy, nothing goes out of their network. So can kubeadm kick off from local artifacts?
Yes, so the local artifacts, you need to have all the images in that's that part. So another thing which I mentioned is resolving of Kubernetes version argument. So the hint here is what default, it has a label and it tries to resolve it. But if you specify it explicitly, saying I want version 1.10.2, it will not go anywhere. It will just use that version.
You can get it from a local registry. You can specify a registry, yes.
Yeah, the similar question, I'd like to add something to it. Can I use a machine that has internet access to prepare that, like pre-package everything in something that you can consume on that very isolated machine?
Yeah, it's exactly the reason why I wanted to say that. So you have few binaries to download, including CNI plugins. Well, if you have some network plugins like VivNet or Calic or whatever you want to use, you download their images. When you have from our download server Docker images, which you can, like on the offline machine, you can say Docker import, and it will import the image. Well, few like infrastructure containers like POS or etcd, like on a machine which you have internet access, you do Docker pull, Docker export, save the files, move it, and then Docker import. So it's all possible.
Maybe the question is there a plan to make that tool which can pack everything offline in your back office? What is a zip file? Yeah, exactly. Whatever it is, instead of everyone.
That's a good question. We've been talking about how to make it easier for people. So there's already a pre-pull images command, so that's part of it. I think we could probably make it even easier. So if you have ideas, please open an issue, right? So and we've been pretty aggressive in the 1.11 cycle about triaging issues.
And please join also our meeting. We are happy to discuss those issues.
We got about one more question, otherwise we'll have to take it afterwards.
I had a question on the kubelet. So the kubelet package is installed from the distribution packages. Is there any plan to run it as a runC container or something directly without Docker, and take it out also as a container for the distro?
So we don't natively run containerized versions because then it becomes a little bit weird with host mount propagation. So other people do that, but the easiest way to give the kubelet the whole system host and to properly use the systemd C group namespace hierarchy is to make it a systemd unifile. Otherwise, you have to do a bunch of extra special tricks to make that all clean and proper. People have asked about it, but it's not been the highest priority thing for us to do because the current implementation usually works for most folks. I do know that other people do this, like it's done inside of kubespray, but kubespray comes with its own complexities and other problems that comes along with it too. So. The Atomic actually has an installation path that works. So Josh Burkus is here. He created an installation path for kubeadm that's well defined and works.
Cool. I think that's all we've got time for.
Yeah. Great. Thank you.
Thank you.